In this example, quite a lot of information. Let's have a look at the question. So we have a certain amount of iron 2 sulfate. We can see that this is a hydrated salt with a certain number of waters of crystallization in it, and we're making it up to 250 in a volumetric flask and taking 25 centimetre cubed portions of it, and we're reacting it with a known concentration of manganate, and we've been given the average titer. You might find it useful to draw a small sketch of the reaction and the experiment that you're going to do here. So we've got a known mass of our iron 2 sulfate, and we're making this up in a volumetric flask to 250 centimetres cubed, and then we're taking 25 centimetre cubed portions of this into conical, and then we're titrating that against our manganate solution like so, and the concentration of the manganate is 0.02 moles per decimetre cubed, and the average titer was 18.5 centimetres cubed. So the place to start will be working out the moles of manganate, and then we can go back and work out the moles of iron, scale up, and then have a look at how we can work out an MR from that. So our moles of manganate from each titration is concentration times volume, so that's 0.02 times 18.5 over 1000, which should give us the moles of 3.7 times 10 to the minus 4. Remember that they're reacting in a 1:5 ratio to get the moles of iron 2 in that reaction. Remember, that's in the 25 centimetres cubed that we used. Simply times that through by 5, and that gives us 1.85 times 10 to the minus 3. But we want to know how much we've got in the 250, so we want to scale up by a factor of 10, which you probably do in your head, but that's just 250 over the 25 that we used, which means that the moles of iron 2 in the 250 is 1.85 times 10 to the minus 2. So we have a moles, and we had an original mass, which means that we're now able to get the MR, which is what we're going to need to work out X in this case. So to work out the MR, that's the mass over the moles. So that's 5.14 divided by 1.85 times 10 to the minus 2, which gives us an answer of 277.8. At this point, just have a think. Does this number look right? If it's 10 times bigger than this, then you've probably forgot to scale up. And so something in the thousands means that you're going to have lots and lots of waters. So probably expect your waters of crystallization to be something from 1 up to sort of low teens at the most. So we're nearly there. The 277.8 is the MR of the whole thing. We just want to subtract the MR of iron sulfate away from that, which was 151.9, which means that our waters are contributing 125.9 to the MR. Each water, of course, is 18, so divide that number by 18 and you'll see it's near as damn it 7, and so the MR, sorry, the formula for this, so 7 waters of crystallization in this salt. Let's run through another example. Don't have iron 2 this time, so this time you can see we've got peroxide, hydrogen peroxide that we're oxidizing. Let's see how the equation works out for this. Well, we're probably fairly familiar with the manganate half equation now. So there it is. In terms of the electrons, we can see that the the hydrogen peroxide takes place with an electron transfer of 2 compared to that of 5. So they're going to react in a 2 to 5 ratio. So let's write the balanced equation. So if we times the peroxide half equation through by 5 and the manganate through by 2, then we end up with this. Hopefully we can see that there's a little bit of tidying up to do. So we've got hydrogen ions on both sides. So we've got 16 hydrogen ions on the left hand side, 10 on the right hand side. So let's lose the hydrogen ions on the right hand side, and we'll lose those 10 hydrogen ions from the left hand side as well, which just leaves us 6 hydrogen ions on the left hand side now, and that's us done for the balanced equation. The upshot being that the peroxide and the manganate are reacting in a 2 to 5 ratio. So our calculation will start with the moles of manganate. So this was the concentration times volume, and that should give us 6.5 times 10 to the minus 4. So to get the moles of peroxide, remember they were reacting in a 5 to 2 ratio, so we want to times by 5 and divide by 2, and that should give us 1.625 times 10 to the minus 3. Now remember that is in 25 centimetres cubed, so we want to scale up to get the moles of peroxide in 250. So we simply want to multiply this through by 10. Which gives us 1.625 times 10 to the minus 2. So this is the moles of peroxide in the volumetric flask, and this is also the moles of the original hydrogen peroxide. So all we've done is dilute it down so the moles remains the same, which means to get the concentration of our original hydrogen peroxide, we just want to use those moles divided by the original volume, which was 25 centimetres cubed, and that should give us a concentration of 0.65 moles per decimetre cubed.